Let us see how we can implement decision tree in Python. So for this session, I'll be using the same old dataset that we used in logistic regression. Uh, Most part of the code is almost the same. Like I did not make any changes over there. So if you do not go through the logistic regression session, I think it is good if you first cover that so that I don't have to repeat the same activity of what I covered in the last session. So this session is purely focusing on what we are going to do in decision tree and how we are going to apply it. Okay. Now, just as a recollection, we have a data set wherein we are trying to predict whether it's going to rain or not based on the given data set. So there were only two classes, class 1 and class 0. And there were a lot of null values, and we applied a lot of logics, find out based on the target we try to identify. We have to go with the mean or with the median and all. So you can just go through that session. I don't want to repeat that. The change what we're going to do is that when we use the model for logistic regression, say in the last session, what we had was we had a pipeline, and the pipeline was used to convert all the categorical columns to one-hot encodings and all the continuous columns to uh, standard scalar values. So that's the change what we're going to do, because the pipeline what we had previous was also having a logistic regression model. Now I don't want to have a logistic regression model. Instead of logistic regression model, I want to have a decision tree. But okay, I just want to keep the models out of the pipeline. So what I'll do is I'll just create a new one more pipeline. I will name it as pipe. Cover this. Okay. I will name that as my pipe, and I will have only preprocessor in it. Okay. In the previous pipeline, we had one addition function, which is nothing but logistic regression model. Now I removed that, and I just want to pre-process. When I say pre-process, after handling all your null values and outliers, we are converting the categorical features to one-hot encoding, and continuous features, we are bringing them to common scale of standard scalar, like -3 sigma to +3 sigma. Okay. And once the pipeline is over, I'll just do a fit underscore transform on x underscore train, and I'll transform on my validation dataset. Now, just keep in mind that the validation dataset is the unseen data for the model. We are going to predict based on X train. Sorry, we are going to train the model based on X train, and we are going to predict based on the validation, the unseen data. Okay. Now, in order to use a decision tree, we will use this model sklearn.model selection. Sorry, sklearn.tree, and under sklearn.tree, we will use decision tree classifier. This is a classification problem. If it is a regression problem, you also have a decision tree regressor. Okay, and we discussed about hyperparameter tuning, right? For the hyperparameter tuning purpose, I'll be using GridSearch CV. Okay, only change from what we did earlier was the pipe, which doesn't consider the model. Now we only have the standard scalar as well as one-hot encoder. Okay, let's move forward. Now what I'll do is I'll just do a fit underscore transform on my train. I'll get my pre-processed train data and my pre-processed validation data. Just like how we did in logistic regression, we are going to do a fit. So I took a classifier CLF, which is nothing but my decision tree. I did not do any hyperparameter tuning. I did not say, I took all the defaults, okay? And then I did a fit. Now let us see how the decision tree performed on the train dataset and the validation dataset. And as I said in the previous session, the decision tree is going to allow the tree to grow completely until it reaches to a point where all the data points are classified to class 0 and class 1. That is where you see this. All of them are ones. It is completely classified, 100% accurate. But when we go and use this model to make a prediction on unseen data, in this case, it is validation, then you see that we have a very bad figure as compared to 1 here. It is 100% accurate, but if you look at this, it is 79. It means it is overfitted. Why it overfitted is it learned all the patterns that is available in the data. we want the model to generalize. Even for a smallest change, we don't want the model to throw out everywhere, we want it to generalize. So in order to generalize, we discussed something called as pruning. Now for that pruning, we will be using a grid search. In grid search, I took only two params for now. I have taken what is my depth of my tree and how many number of splits I can allow the tree to make. So I said you should consider only max 3 depths. I mean, it tends to calculate only 3 times. It can split only 3 times. And every time it splits, it can make only 3 child nodes to a maximum of 3 child nodes. Now, what this library grid search CV does is it will try to make decision tree in each combination. Now, let us say we have 6 different values, right? So it will make 6 combinations of decision trees and finds out which decision tree is more good. And it does 10 times. So a total number of 60 decision trees will be made, but eventually we'll be using only 6. The other 10 is used only for cross validation. So I just want to show what is cross validation now. Let us say that we have a data set like this. Just let me annotate for you so that it will be easy for you to understand. Now I have a data set like this. This is my X tree and this is my Y tree. What I'll do is I'll try to divide this data set into 3 parts. Let us say I'll say cross validation is equal to 3. What it'll do is it'll try to divide the data into 3 parts. This is your first data. This is your second data. Now what it will do is it will take model 1. It is trying to make like 6 models, right? For the first model, it will take these 2 as the train and this for the test. Okay, so model 1 uses, let us say this is part 1, part 2 and part 3. So it will take 1 and 2 for train and 3 will be used for testing. Again, then what will happen is 1 and 3 will be used for training, 2 will be used for testing. Then it will use 2 and 3 for training, 1 will be used for testing. So simultaneously it is keeping one chunk for prediction and it will try to figure out what is the score in each of these tests. Say you will have some 97, let us say you have some 98, maybe here 95. If all the scores are very similar to each other, then the model is robust. It is not fluctuating with slightest change in the data. But let us say if there is a case wherein you have 99, then you have 81, and maybe you have 95, it means that the model is not robust. There may be a chance of overfit just because the data set is the combination in which the data set was passed to the X train, you are getting a good number. But just in case if you take a different random state, you will find the model to be fluctuating or deviating quite a bit. That is why we use cross validation. Cross validation is only to see if the model is robust or not, but it is not going to improve the model's performance. It is only for validation purpose that my model is not sensitive to any unforeseen incidents, like if you have an outlier, is it sensitive to outliers or not, or some kind of a different data that is present in one of the records and so on. So based on that sensitive changes, my model is going to perform the same or it is going to perform very badly. So just keep in mind, if all the scores are similar, then your model is robust. If the scores are deviating far from each other, then the model is not robust. Okay, that is why we are using grid search CV. And in the CV, what we are trying to do is we are trying to pass something called as params. Now, what is a params? This is the hyperparameters. What is the depth of tree I can allow to grow, and what is the number of splits I can allow? And I'm passing it to my grid search. Now, it will simply build that and it will give us the best tree where the combination is having the lowest error. Okay, So it did all these 60 iterations, and it said that the best score is 82, and the maximum depth is 3, and the minimum number of sample bit is 1. And then what we'll do is we'll go and predict using that best estimator. I want to predict based on the best estimator, right? So I'll say grid dot best estimator dot predict, and we'll pass both our train and validation, and we'll get our y hats. Now let us see what is the values. Now if I look at y hats from train, I'm getting like this, like the 84 and 0.34. It is not really good on class 1, but we have much better than what we had earlier, wherein all the values were 1. And now if you go and compare the validation data set, here the scores are almost similar. You can see the numbers are almost same. Though the overall model is not too good, but at least it is not overfitting. It is not giving you false values. Okay. Still there is a scope of improvement. Maybe decision tree is not sufficient for this kind of a data set. You might have more complicated models which can resolve this. One common issue that we see in classification is class of imbalance. Okay, this is highly imbalanced data set wherein you have more number of records from class 0 and less number of records from class 1. So as we move forward in the decision tree and in the machine learning courses, we'll try to also see how we can deal this weight imbalance data sets. Okay. I hope this is very clear. I mean, this is a very short video about decision trees implementation in Python. So just try and see if you can replicate this in your environment. I'll try to upload this notebook in our Git Git URL, and then you can download it from there. Thank you so much.